Freeman Dyson, the Sun, the Genome and the Internet, Tools of Scientific Revolutions. Dive into the revolutionary world of science and technology as renowned physicist Freeman Dyson explores the fascinating intersections of solar power, genetic engineering, and the Internet in his book The Sun, the Genome and the Internet, Tools of Scientific Revolutions. Discover how these powerful tools have the potential to change the world and foster social justice, transforming lives by blending practical applications with ethical considerations. Gain an understanding of the importance of scientific innovations and their contribution to a sustainable and equitable future, as Dyson delves into gripping historical examples and envisions futuristic possibilities for humanity.
The usefulness and power of science. Godfrey Hardy argued against applied science, claiming it promotes inequality and destruction. However, science can be useful without being harmful. John Randall, the inventor of the cavity magnetron, brought revolutionary changes in astronomy, nuclear physics, and molecular biology by creating tools that drove scientific discoveries. His work with X-ray crystallography ultimately led to the understanding of DNA. As Randall said, the game of evolution, like the game of chess, will in the future be played by humans and machines working together. Therefore, science, although it can be misused, has the potential to make significant contributions to the betterment of humanity. Science and crafts, a fusion for progress. Science is not a product of a single tradition, it is the product of a blend between the tradition of philosophical thinking and skilled crafts. Tools provided the instruments for scientific discoveries, and philosophy supplied the concepts. Initially, science and the crafts industry developed separately, but they later became linked in the 20th century. The craftsmanship era of computer manufacturing is coming to an end, but software writing still flourishes as a craft industry. Scientific revolutions mainly arise from new tools rather than new concepts. In his discovery of DNA sequencing, Fred Sanger inventively developed the necessary technical tools. Nature invented viruses to provide tools for research that combine standardization with variety and specificity with cheapness. The future of artificial viruses will revolutionize science in innovative ways. Sustainable versus unsustainable scientific projects. A sustainable scientific project must be inexpensive enough to be continued indefinitely without political battles, while an unsustainable project marks the end of an era. The Internet has made it possible to link telescopes into a network that could discover a new planet every 4 years at a cost of less than $100,000, emphasizing the importance of being opportunistic and cheap. Medical scientists could revolutionize the field with the invention of a desktop gene sequencer and protein microscope, allowing for faster progress and diversification without restraint. 3 technologies for a just world. Solar power, genetic engineering, and the Internet have the potential to create a socially just world, but ethics must guide technology in the direction of social justice. Space travel is irrelevant, but space communication will be important. Each advance in technology tends to come with a step backward, and ethics must guide technology towards social justice. In the coming century, solar power, genetic engineering, and the Internet will be the 3 most important technologies that have the potential to create a socially just world. These technologies could enable every Mexican village to become as wealthy as Princeton, New Jersey. However, in order for this to happen, ethics must guide technology in the direction of social justice. While communication through space will be important, space travel will become irrelevant. Instead, there will be a global Internet carried by a network of low-altitude satellites linked by radio and laser communications. This could lead to a socially just world. Historically, technology has contributed to social justice on numerous occasions. For example, the invention of printing in 14th century Europe brought books and education to the people on a wide scale. Additionally, technologies such as public health, clean water, sewage treatment, vaccination, and antibiotics protected both the rich and the poor. Furthermore, the technology of synthetic fabrics and household appliances helped destroy unjust class systems by making stylish clothing and domestic tools cheaply available for everyone. However, each advance in technology tends to come with a step backward. For instance, women of the master class enjoyed great liberty and scope for achievement in England during the early years of the 20th century, but the technology of household appliances liberated the servants and shackled their mistresses. Ultimately, ethics must guide technology in the direction of social justice, ensuring that technological progress serves as a tool to relieve tensions between diverse ways of life and create a world that is economically and socially just. Solar power and poverty. In the fight against rural poverty and population explosion, solar power is a potential solution. A working solar energy system has the power to improve the quality of life in tropical villages. However, such systems are currently too expensive for most households. The main costs are related to photovoltaic collector panels, and this is preventing solar energy from being used on a large scale. Cheap solar energy can be achieved through genetic engineering, but before we reach that point, we must tackle poverty in rural areas before we can hope to reduce population growth. Energy-efficient fuel crops. The future of energy supply could be a large forest of genetically engineered trees, converting sunlight to liquid fuel with 10% efficiency, equivalent to photovoltaic collectors. This would create a strong economic incentive for landowners to grow trees, selling the fuel for $10,000 per year per acre. Traditional genetic engineering took centuries or millennia to produce desired mutations in crop plants and farm animals, but modern geneticists can produce mutations in just a few years. Within a few decades, we will understand the genome well enough to breed trees that turn sunlight into fuel while preserving the diversity of natural forests. This could help reverse poverty and the population explosion in our quest for a better future. Global Internet Revolution. The Internet has enabled remote areas to be part of the global economy and will end cultural isolation for poorer countries. In the future, a global network of low-orbit satellites will connect even the most isolated villages. The teledesic system, utilizing 288 satellites, already provides global connectivity with minimal delay. The ricochet system, invented by Paul Barron, utilizes wireless transmitters and receivers to eliminate expensive cable connections. New technologies offer real opportunities for making the world a happier place. The future of space missions. The U.S. space program's pursuit of two objectives, practical use of space and human adventure, has led to space science becoming extravagant while ground-based astronomy has become parsimonious. The author suggests that all space science missions should be cheap, and there are 3 ways to cut costs: reduce staff, develop new launch systems, and rely on unmanned missions. The next 50 years will see the era of cheap unmanned missions, which will prepare the ground for the era of cheap manned missions. The author proposes genetically engineered, warm-blooded plants to grow greenhouses and collect energy from mirrors for a considerable population of plants, animals, and humans. Ultimately, emigration must happen to relieve the tension between diverging ways of life, where some will find new places to live away from Earth while others stay behind.
In The Sun, the Genome, and the Internet, Freeman Dyson illuminates how scientific revolutions can shape a more socially just world. By exploiting the potential of solar power, genetic engineering, and the Internet, we can bridge socioeconomic divides and uplift disadvantaged communities. However, the pursuit of such progress must be guided by ethical principles that ensure fairness and equity. While the future holds remarkable prospects, we must learn from the past and the pitfalls of rapid advancements. The interplay of these 3 groundbreaking technologies can pave the way towards a better, more equal, and sustainable world, turning Dyson's dreams into reality.